All right, you are welcome again. Today, let's take a look at this question. Find the integral of 1 plus x all over 1 plus x squared dx. Okay, we are asked to evaluate this particular integral. I want you to pay attention to this. It's very simple, okay? Now, let's go. Solution. Look at this. When you see this kind of integral, here you cannot use substitution method. We are actually going to split this rational polynomial into two, okay, like this. Now look at this. Here we have the integral of 1 all over 1 plus x squared plus x all over 1 plus x squared. Now when you look at this very well, you see that the denominator is the same, right? And then the numerator is having 1 and x. Okay, so you see that if you are to add these together, it's going to give you our original equation. Are we together? Now let's go. Look at this. We see that this particular problem that we are being given can be splitted into two like this. And once you succeeded in splitting it into two, so we take their individual integral. Okay, so once you succeeded in splitting into two, then we take their integral differently. So that means we are going to have the integral of 1 all over 1 plus x squared dx plus the integral of the second one, which is x all over 1 plus x squared dx. Are we together? So here we splitted it into two, and then we take their separate integral, or we take the integral separately. Okay, so at the end of the day, we are still going to join them together. Are we together? Now let's go. Let's pick the first part. Now look at this first part. This first part, we have the integral of 1 all over 1 plus x squared dx. Now if you look at it very well, you will discover that this is a standard integral. This is a standard integral. Is a integral of a basic function or elementary function, which is tan inverse of x, or we call it arctan x. All right, is a basic or a standard integral. The integral of 1 all over 1 plus x squared dx. Now you see that this one is different from the second part of it. We are going to see the difference. Okay, so this particular one, 1 all over 1 plus x squared dx, is a standard integral. And this standard integral, the answer is what? Tan inverse of x, or you can say arctan x. Okay, arctan x. All right, good. Let's keep these separate. Now let's pick the second part of this integral. The second part says the integral of x all over 1 plus x squared dx. All right, good. Now look at this. You see that this one here is almost the same with the first part, but it's not the same, right? Because the numerator in the first one is just 1, and the numerator in the second part is x. Okay, so now look at it. What we're going to do, we're going to use substitution method for this. Are we together? So we're going to say let u equal to 1 plus x squared. The denominator, let's call it a letter u. Now this new variable u that we want to introduce, we find the derivative of it. That is, we differentiate it, because this u now is a function of x. Then we're going to differentiate this u with respect to x. So we have du dx. So when we differentiate, it's going to give us 2x. When we differentiate 1 is a constant, it's going to give you 0. And when we differentiate x squared, it's going to give us 2x. From here, we cross multiply. When we cross multiply, we're going to have du is equal to 2x dx. All right, good. Now pay attention to this original integral we have. This is, this second part. We have the integral of x all over 1 plus x squared dx. Now you can see that the numerator is x dx. X dx. We have x dx. Are we together? So here we can make x dx the subject. Okay, so if we make x dx the subject, that is to say we're going to divide both sides by what? By 2. So we divide both sides by 2, we are going to see that x dx is standing alone, is equal to du all over 2. So now we are going to substitute properly. The denominator, we say let's replace it with u, and then x dx is having a new variable, or is having a new term to it now, which is du all over 2. So let's substitute properly. Here we have the integral of x all over 1 plus x squared dx. Can we substitute? Yes. Look at this. We have x all over 1 all over 1 plus x squared. This 1 plus x squared, the denominator, can be replaced with u, and then we're going to have 1 all over u times this x dx can be replaced with du all over 2. So here we have multiply by du all over 2. Now we can factor out 1 all over 2 here. Are we together? So when you factor out 1 all over 2, we're going to have 1 all over 2 is a constant. We take it behind the integral sign. Then 1 all over u du. I don't know if you get what we did here. Are we together? Yes. Now pay attention, it's very important and it's very simple, right? Good. So here now we have 1 all over 2, the integral of 1 all over u du. We can now integrate properly, right? Good. We keep the constant behind, right? And then integrate what we have after the integral sign. So here we have 1 all over u. Integrating 1 all over u with respect to u is going to give you ln u plus c. Okay, ln u plus c, but you recall that u is 1 plus x squared. Let's substitute it back. We're going to have 1 all over 2 open bracket ln u, we replace u with the real value, which is 1 plus x squared, all right, close the bracket, plus c. Okay, so this is the second part. Yes. Now we see that we splitted this integral into 2 parts, first part and second part, and we see that the first part is a standard integral, which is tan inverse of x, and then the second part we evaluate, and we are having 1 all over 2 ln 1 plus x squared plus c, right? Now we bring it together, okay, because we say first part plus the second part. Now when we bring it together, we see that the integral of 1 all over 1 plus x squared dx plus the integral of x all over 1 plus x squared dx is tan inverse of x plus 1 all over 2 ln 1 plus x squared plus c. Hello, are we together? Yes. We see that the integral of 1 plus x all over 1 plus x squared dx is giving us tan inverse of x plus 1 all over 2 ln 1 plus x squared plus c. Okay, please, I want you to watch this over and over for you to get the concept. It's very simple. All right. Yes, thank you very much for watching. Please, if you are new to our YouTube channel, do well to like, subscribe and share our videos. Stay blessed. Let's take more examples.